Dundigal. Myself Sreevani, working as an assistant professor in the Department of Electronics and Communication Engineering in Institute of Aeronautical Engineering, Dundigal, Hyderabad. So in today's lecture, we are going to learn about problems which are associated to the Gauss law in electromagnetic waves and transmission lines. We are going to learn in this particular lecture. Okay. So before going to solve some of the problems based upon this Gauss law, so what is a statement related to this Gauss law and a mathematical equation? Then from this, we'll be evaluating some of the problems which are given here. So Gauss law states that the flux passed through any closed surface is same as that of the net charge enclosed by that surface. See, the flux which is passing through any closed surface is represented with psi, and which is equal to the total charge enclosed by that surface is resembles with Q enclosed. So psi which is passed through any closed surface means the closed surface means closed surface integral S. Flux passing through any closed surface means it occupies some area. That distance is given by here electric flux density, and it is also called as electric displacement D into ds is equal to charge enclosed by that. Charge enclosed means we are closing the two surfaces, then it leads us volume. Hence integral V rho V dV. So psi is equal to integral S closed surface integral S d dot ds, and Q enclosed is equal to integral V rho V dV, where d is said to be electric flux density and rho V be the volume charge density. Right? So depending upon this, the Gauss law, we are going to solve some of the problems. So the first problem is given is here a square plate described by -2 less than or equal to x less than or equal to 2, and y is ranging from -2 to 2 and z is equal to 0. So z is equal to 0 plane means we are talking with xy plane or z equal to 0 plane. Right? So xy plane means here the two variables are x and y, and we are supposed to integrate with the area with x and y. So a square plate described by -2 less than or equal to x less than or equal to 2, and -2 is less than or equal to y less than or equal to 2, and z is equal to 0 carries a charge. Carries a charge 12 modulus of y millicoulomb per meter square. Means we are suppose if we consider this charge is given as 12 into modulus of y. Sometimes we used to consider it as plus y, and sometimes we used to consider it as minus y. Why? Because here modulus of y is given. So for this we are considering either positive values or negative values. Millicoulomb per meter square. Where flux density or surface charge density is measured. Surface charge density means it is represented with rho s, and it can be measured in coulomb per meter square. Generally, electric flux or electric charge is measured in coulombs, and it occupying some area means it is measured to be per meter square, and we are expressing that in terms of milli, hence rho s is expressed in the given sum is millicoulomb per meter square. Then find the total charge on the plate and the electric field intensity at 0, 0, 10. So first we need to find the total charge which is associated on this plate, means charge enclosed as Q. So Q equal to, the formula is given as integral S d dot ds. Right? So according to the Gauss law, psi is equal to Q enclosed, psi equal to Q enclosed. Now from this total charge Q equal to integral S d dot ds, or which is equal to integral S rho s into ds. Right? So rho s is given, that is 12 into modulus of y millicoulomb per meter square. Right? So Q enclosed is equal to surface integral S. Integral S stands for, we are supposed to consider it in terms of two directions as xy or sometimes yz or sometimes zx. So now here two variables are given as x and y, hence we are considering the formula for ds is given as ds is equal to dx dy, right? So now rho s means 12 into modulus of y into millicoulomb per meter square into 10 power minus 3 into dx dy, right? So this here, the x and y variables are ranging from -2 to +2 and -2 to +2, right? Now we are going to split this 12 into modulus of y, means q equal to integral x is equal to -2 to 0 into 12 into y into 10 power minus 3. For the negative values, it is to be minus 12y into 10 power minus 3 into dx dy integral y equal to -2 to 0. Then plus integral 0 to 2. Then integral means x is equal to and y equal to 0 to 2. Then 12 into y into 10 power minus 3 dx dy. Right? So here 12 into modulus of y is given, where this modulus of y value is splitted for the negative values as ranging from -2 to 0, and for the positive values it is ranging from 0 to 2. Right? So if you are going to evaluate this one, means minus 12 into 10 power minus 3 is common, and if you are integrating this one with x limits as -2 to 0, and for y it is y square by 2, and if you substitute limits as -0 to 2, this is the evaluation for the first integral. Then plus 12 into 10 power minus 3, and again if you are integrating with respect to x, it is x, then limits are 0 to 2, and y it is y square by 2, limits are 0 to 2, right? So now if you evaluate the complete one, means in between 2, the 12 into 10 power minus 3 is common between 2, and if you substitute 0 here, first minus as common here, minus, then 0 minus of -2 plus 2, then if you substitute upper limit as 0 and lower limit as -2, then -2 square becomes plus, means 4 by 2. This is for the first. Then again if you consider here, plus 12 into 10 power minus 3 into x square, x value. If you substitute upper limit as 2, then 2 lower limit is 0, means 2 into, and upper limit is here again 2, 2 square is 4, 4 by 2, it becomes 2, right? Which is equal to 12 into 10 power minus 3 into. So minus 2 and 2 gets cancelled here. So 2 into 2 becomes -4, then here 2 gets cancelled, then plus 12 into 10 power minus 3 into, this becomes 4. So if you evaluate the complete thing, you're going to get the value as to be given by 192 millicoulombs. Or this is the one of the procedure, or else we are going to evaluate this one as another way, as q equal to integral s rho s into ds is equal to, means 12 integral s means x is equal to -2 to 2, y equal to -2 to 2, then 12 modulus of y into millicoulombs, that is 10 power minus 3 dx dy. So this is the way, if you evaluate this one, 12 into minus y value is for the negative and y value is for the positive values. Like that, if you are evaluating, the complete value for q is to be obtained as 192 millicoulombs. Generally, the charge can be measured in coulombs, and already it is represented in milli, hence we are writing for the units as for charge is 192 millicoulombs. Now from the along with the charge, see, find the total charge on the plate and the electric field intensity at 0, 0, 10. Generally, the electric field intensity E of 0, 0, 10 we need to find. So E related to this charge density, means E is equal to integral S rho S ds by 4 pi epsilon naught r square into AR. Why? Because this one is given by here, the surface charge density is given as, that is rho s, and the formula for ds is given by according to the plane, that is ds is equal to dx into dy, and electric field intensity E must be always a vector, hence we are writing the unit vector as here AR, right? So rho s into ds, rho s value is given as 12 into modulus of phi, and x and y values are ranging from minus 2 is less than or equal to x comma y is less than or equal to 2 is given, and 4 pi epsilon naught value 1 by 4 pi epsilon naught value, which is equal to 1 by 4 pi into 8.854 into 10 power minus 12, or 1 by 4 pi into epsilon naught value, sometimes we may consider it as 10 power minus 9 by 36 pi. So that is 10 power minus 9 by 36 pi. So pi gets cancelled, 4 and this gets cancelled, which is equal to 9 into 10 power 9 as approximately value of this 1 by 4 pi epsilon naught. So in place of this 1 by 4 pi epsilon naught, if we substitute 9 into 10 power 9, and here 9 into 10 power 9, and integral x is equal to minus 2 to 2, y equal to minus 2 to 2, then rho s value 12 into modulus of y, dx is dx into dy as AR. AR means, as we know that unit vector AR is equal to R by its magnitude. Then R is given as from the surface to origin to the field we are going to evaluate at 0, 0, 10. So x, y values are 0 and 0, z is given as 10. Hence, we need to find the distance between 2 as 2 means R is given as x, y, 0 minus 0, 0, 10 are given. So xax plus yay plus 0 minus 10 means minus 10 az is the value of R. Now from this AR equal to R by means xax plus yay plus zaz means z means that is minus 10 az by magnitude means root of x square plus y square plus 100. Right? So this is the value of AR, and if you substitute here in the R square, then this becomes x square plus y square plus 100 whole power 3 by 2. So like that, if you simplify, means AR value is xax plus yay minus 10 az by R means x square plus y square plus 100 whole power 3 by 2. So if you evaluate the complete equation, then already rho s is expressed in terms of 10 power minus 3 milli, hence E can be expressed something into AX plus something into AY plus something into AZ, like that is supposed to get. Why? Because always this electric field intensity E is to be expressed in terms of vectors. So from that, here is given as 16.46 AZ is the value to be obtained for this electric field intensity, and the unit for this electric field intensity is volts per meter. Right? So this is the way we have been evaluated for the problem related to the Gauss law. According to Gauss law, psi equal to q enclosed, then from that psi is equal to, will be evaluated as such. Now D, determine D at 4, 0, 3. Electric D is the notation for electric flux density. Then determine D at 4, 0, 3 if there is a point charge minus 5 pi millicoulombs at 4, 0, 0 and a line charge 3 pi millicoulomb per meter along the y-axis. See, suppose if we have the three directional view of a given sum is x, y and z. On the y-axis, see, particularly they will mention it as line charge is located on the y-axis. Means here it will be rho L, and which is given as 3 pi millicoulomb per meter. Generally, the line charge, the charge, electric charge can be measured in coulombs and it is represented with Q. Now we are talking on the line charge, hence it is represented with rho L, and its value is given as 3 pi millicoulomb per meter. Now from this, rho L is located on the y-axis, and D at 403, if there is a point charge minus 5 millicoulombs at 4, 0, 0, means on the x-axis the point charge Q is located. So here Q is located at 4, 0, 0, and D is at 4, 0, 3. So we need to find the total D, electric flux density D, due to point charge as well as the line charge. So that can be written as D equal to dq plus dl. So the formula for dq is given by the flux density due to a point charge is given by, that is, q is given as minus 5 pi millicoulombs, and here it will be 3 pi millicoulombs. So q by 4 pi epsilon naught r square into AR is the formula for dq. And similarly for dl is given by rho L by 2 pi rho. Sorry, there is no epsilon here. Why? Because d we are evaluating, as we know that d equal to epsilon naught into E. Then in place of E, if we substitute the formula which is related to a point as well as the line, then epsilon gets cancelled. Then here d by 4 pi r square into AR. Q by 4 pi r square into AR. Right? So then Q value, if we substitute, Q is here minus 5 pi into 10 power minus 3 by 4 pi into, means AR by R square. So AR value, how you are going to evaluate, means R by modulus of R, then R is given by, it is the distance from 400 to 403. So D2 means 4, 0, 3 minus 4, 0, 0 by magnitude, means root of 4, 0, 3 minus 4, 0, 0 magnitude. Right? Which is equal to 4 minus 4 as 0 minus 0 plus 3 by, again this thing becomes 3. Why? Because 4 minus 4 0, and this and root over this 3 square becomes 3, and 3 gets cancelled. AR value as 1, means 3 AZ. Right? So 3 gets cancelled. AZ is to be obtained, that is AR value. Similarly, for this thing, DL is equal to rho L by 2 pi rho into A rho. Now from this, rho L by 2 pi rho into AR. See here, DL is equal to rho L by 2 pi rho into A rho. So rho L value is given, that is, from the given rho L value 3 pi millicoulombs, that is 3 pi millicoulombs, means 3 pi into 10 power minus 3 by 2 pi rho. Rho L value, that is rho, is the distance from, again here, A rho is equal to rho by its modulus of rho, and rho value is to be obtained at 4, 0, 0. Right? 4, 0, 3. So that is given by here. See, rho value 4, 0, 3 by root of 4 square plus 3 square, which is equal to 4ax plus 3az by 4, means root 4 square is 16, 16 plus 9 is 25, root 25 value is 5. Then 5 into 5 means here A rho value 4ax plus 3az by root square is to be obtained. So 5 square gets cancelled, again it is p, 5 pi gets cancelled, 3 by 2 into 4ax plus 3az by 5 into 10 power minus 3 is the value of dl. So if you finally evaluate the flux density D due to surface and line and point charges, means that is dq plus dl, which is equal to q by 4 pi r square into AR plus rho L by 2 pi rho into A rho. Now if you evaluate the total thing, the electric flux density D due to line as well as the point charges, hence it is to be obtained as value, that is 240 AX plus 42 AZ microcoulomb per meter square. Micro means we are writing means the total thing is multiplied with 10 power minus 6, and for this 10 power minus 6 we are representing it as with micro. Hence the flux density due to line as well as the point charge is given by here from the given problem, 240 AX plus 42 AZ microcoulomb per meter square. So generally the flux density D can be measured in coulomb per meter square, and extra factor is multiplied with the resultant is with 10 power minus 6, and for that we are writing it for as 10 power minus 6 as micro. Hence the answer is to be obtained as 240 AX plus 42 AZ micro coulomb per meter square. Next, again the problem on Gauss law. So given that D is given as D equal to Z rho cos square phi AZ coulomb per meter square, and calculate the charge density, means the charge density at 1 comma pi by 4 comma 3, and the total charge enclosed by the cylinder of radius 1 meter with minus 2 is less than or equal to Z is less than or equal to 2 meters is to be obtained. See here, calculate the charge density. Charge density means the charge which is associated with the flux density is resembles with rho v. Now according to Gauss law, that is psi is equal to q enclosed. Now in the integral form it can be written as closed surface integral S d dot ds is equal to integral v rho v d. By applying divergence theorem to this integral form, then from this the point form or differential form of the Maxwell's equation, which is to be obtained from the Gauss law as rho v equal to del dot d. Right? So given that d is to be Z rho cos square phi AZ coulomb per meter square, then calculate the charge density. Rho v we need to find at 1 comma pi by 4 comma 3, and from that the total charge enclosed by the cylinder, means the total charge which is enclosed is resembles with q enclosed. Now here from this we are going to evaluate q enclosed by the cylinder of the radius is given as 1 meter. Right? So cylinder radius means we are writing the notation as for rho. Now see, in order to evaluate the total charge, first we have to find the charge density which is associated with flux density D. So D is given as D equal to Z rho cos square phi AZ coulomb per meter square. See, if you observe the given D, Z rho phi are the three variables. Rho phi Z variables are given means given coordinate system is cylindrical type coordinate system. Rho phi Z are the variables. Now from these variables, we'll be first identifying what are the differential components. Why? Because in order to write the surface area or volume or line charge formulas, we need to find first differential components of the given coordinate system. So given is a type of cylindrical type, hence we are writing the differential components as for the rho it is d rho, for the phi it is rho d phi, and for z it is dz. What about this rho and the z components are directly written as d rho and dz, but here in order to write this phi component we have to consider along with its radius. Why? Because here we are finding length of an arc. This is phi. Length of an arc means we need to find the formula L is equal to r theta. R is given as radius of a cylinder and it is resembles with rho, and theta is given by for the differential component as d phi. Right? So differential components for the cylindrical coordinate system as d rho, rho d phi, and dz. Okay. Now from that first d is given. So the relation between d and rho v is given by according to the point form or differential form of the Gauss law as rho v equal to del dot d. So rho v equal to del dot d. So del dot d is given by d is a vector, and del dot d stands for here divergence of electric flux density. So divergence of electric flux density, the formula is given by dou by dou rho into rho aero plus, aero plus 1 by rho dou by dou phi of rho a phi plus dou az by dou z, right? So dou by dou rho of aero means here d equal to z rho cos square phi az, means only z component is given. It is represented with az or dz, az or dz. So in place of dz only, we are writing the component as, means rest of the two becomes 0. Then dou by dou z of az value or dz value is given. So dou by dou z of az means z rho cos square phi az coulomb per meter square, which is equal to. So now here differentiation is with respect to z, means the rest of the two are constants. That is rho cos square phi as constant, and in place of z, if we substitute as differentiating this one with respect to z is 1. Rho cos square phi is to be obtained. Now calculate the charge density at 1 comma pi by 4 comma 3, means r rho phi z values are given. Rho equal to 1 and phi equal to pi by 4 and 3 is the value of z. So in place of rho phi z by 1 pi by 4 3, if we substitute, we'll be getting the value of the charge density. So rho value is 1 and cos square phi is here pi by 4. So pi by 4 means it's a value of 45, that is cos square 45. Cos 45 as 1 by root 2. Cos square 45 means 1 by 2, that is 0.5 has to be obtained. Its value as rho v. Okay. Now from this rho v, we are going to evaluate the charge which is enclosed by the cylinder of radius. Means charge enclosed means the formula here q enclosed is equal to integral v rho v dv, right? Which is equal to, so integral v means we are writing the integration for three variables, means it's, so here we are talking about cylindrical coordinate system, means rho equal to phi equal to z equal to. So rho is the radius is given as 1 meter, hence 0 to 1 meter is given. Z is also ranging from, z variable is given, that is -2 to 2. So z equal to -2 to 2, and phi is the variable which is ranging from 0 to 2 pi. We know that generally. And the formula for dv is given in the cylindrical coordinate system, and the differential variables are d rho, rho d phi, and dz. Right? So if you multiply 3, then dv formula becomes rho d rho d phi dz. Right? So triple integral first. Rho equal to 0 to 1, phi equal to 0 to 2 pi, and z is equal to -2 to 2. And the value of rho v is to be obtained before substituting the limits. So before substituting, its value is rho v, rho cos square phi. Right? So now substitute in place of rho by rho cos square phi into dv, means rho d rho d phi dz. Right? This is the way we need to write first. Then integral. So integration with respect to the separate variables as like this. So rho into rho becomes rho square. If you are integrating rho square, then rho cube by 3 is to be obtained. Then its value is ranging from 0 to 1. And cos square phi. So for this, we are writing the formula as integral phi is equal to 0 to 2 pi. Then cos square phi means 1 plus cos 2 phi by 2 into d phi. And z, if we substitute z values like this, 2 and -2, right? So then rho, if we substitute upper limit as 1, then 1 by 3 into, and if you are integrating this one as 5 by 2, then plus sine 2 phi by 4. If you substitute limits as 0 to 2 pi, and z value 2 minus of -2 becomes 4. So 1 by 3 into, we substitute pi by 2 pi first, 2 pi by 2, then plus sine 4 pi by 4 minus 0 minus 0 into 4, right? So which is equal to 1 by 3 means 4 by 3. 1 by 3 into this 4 becomes 4 by 3 into 2 pi by 2. 2 gets cancelled pi and plus sine 4 pi value is 0, then which is equal to 4 pi by 3, right? This is the value is to be obtained for charge enclosed by that surface. See here. So Q equal to 4 pi by 3 and Q can be measured in coulombs is to be obtained, right? So first, what is the given data means? From the given D equal to Z rho cos square phi Az coulomb per meter square is to be given. Now calculate the charge density means the formula between rho v and D is given by rho v equal to del dot D. Use this as the formula to solve rho v, and after obtaining rho v, we need to substitute rho phi z variables by 1 comma 5 by 4 comma 3, and from this rho v we are going to evaluate the total charge which is enclosed by that radius. Okay, so this is the way we have been evaluated, hence we have got the charge enclosed by that surface is 4 pi by 3, and units to measure this charge is coulombs. Next one is, if D equal to 2y square plus z into ax plus 4xy into ay plus xaz. If D equal to 2y square plus z into ax plus 4xy into ay plus xaz coulomb per meter square. Then find first value we need to find as volume charge density. Volume charge density means the notation for that is rho v. Generally charge is represented with Q, and here volume charge, and we are writing it as rho v at minus 1 comma 0 comma 3. Then the flux through the cube defined by, means psi we need to find. Flux notation here we are using in this electric fields as psi, and flux through the cube defined by means the variables are given as x, y, z, and 3 are ranging from 0 to 1 meters. Then the total charge enclosed by the cube means from this you are going to evaluate Q, right? So most probably here we are using Gauss law, means according to Gauss law Q enclosed is equal to psi. Means in both the cases, means in the part B and the C case, you are supposed to get the same value, that is 2 coulombs and 2 coulombs. So to get this, the values are same. First we need to evaluate first value as the volume charge density. So the relation between volume charge density and electric flux density is given from the point form or differential form of the Gauss law is rho v equal to del dot D. Generally D is a vector and it is expressed in terms of D equal to dx ax, dy ay, and dz az. Okay, now from this formula for this del dot D is given by dou dx by dou x plus dou dy by dou y plus dou dz by dou z. Okay, which is equal to dou by dou x of dx means dou by dou x of dx is 2y square plus z plus dou by dou y of dy is nothing but 4xy plus dou by dou z of dz in the sense x, right? Which is equal to dou by dou x of 2y square plus z. So we are differentiating this one with respect to x, and the variables are given by y and z. So with respect to x, these two are constants, hence this will be 0. Plus dou by dou y of 4xy. So 4x is to be a constant, and we are differentiating this one with respect to y. Then dou y by dou y value is 1, hence we are getting here the value as 4x. Plus dou by dou z of x. We are differentiating this one with respect to z, and the variable is given as x, and x can be treated to be a constant, hence its value becomes 0. Then rho v equal to 4x. Here. And the volume charge density at minus 1 comma 0 comma 4 0 comma 3 means substitute x y z means x value is minus 1, y value is 0, and z value by this 3. Now if you substitute x, y, z by minus 1, 0, comma 3, then we are going to get rho v equal to 4 into minus 1. Why? Because its value is minus 1 x value and it's minus 4, and rho v is to be measured coulomb per meter cube. Generally, charge is measured for the point charge, it is to be measured as coulombs. For line, it is coulomb per meter. For surface, it is coulomb per meter square, and for volume, it is coulomb per meter cube. Hence, rho v equal to minus 4 coulomb per meter cube. So, see here, for the volume charge density, its value is minus 4 coulomb per meter cube is to be obtained. Now, similarly, the flux through the cube is defined by, means before going to evaluate this one, first we need to evaluate this, the total charge enclosed by the cube. So that is given by total charge enclosed by the cube means Q enclosed is equal to integral V rho V dV. So the formula for rho V means integral volume means we are integrating that one with respect to 3, that is x is equal to y equal to z equal to. So x is ranging from 0 to 1, y is also ranging from 0 to 1, z is also 0 to 1. And the rho v value is to be obtained as before substituting limits means 4x. So this 4x we have to consider here. In place of rho v, if we substitute 4x, and the volume for means x, y, z are the variables are given in the D. Hence, given coordinate system is a type of rectangular coordinate system. For a rectangular coordinate system, variables are x, y, z, and the differential components are dx, dy, dz. And the volume formula becomes dv equal to dx, dy, dz. Hence, in place of dv, we are substituting dx, dy, dz. Right? So, integral. Then 4 is a constant. X means x square by 2. Limits are 0 to 1. And y 0 to 1. Z is also 0 to 1. So, there is no variable here 1. We are integrating 1 with respect to y means its resultant will be y. Substitute limits are 0 to 1. Similarly, for z, it is 0 to 1, which is equal to 4 into. We substitute upper limit as 1, 1 by 2, lower limit becomes 0. Then y is also 1 minus 0. Z is also 1 minus 0, which is equal to 4 into 1 by 2 into 1 into 1. So it becomes 2. Charge enclosed, no, Q enclosed, which is equal to 2, and it is measured in coulombs. Hence, Q enclosed is equal to 2 coulombs is to be obtained. So similarly, charge, the flux through any closed means this is part C. Related to part B, we are going to evaluate flux psi. So psi is equal to integral S d dot ds. Right? So d dot ds, integral S, integral x is equal to y equal to d dot ds. ds means dx dy plus integral y because closed surface integral S d dot ds. Where this closed surface integral means first we are going to evaluate with respect to xy plane, that is 0 to 1, 0 to 1, d dot dx dy plus integral y equal to 0 to 1, z is equal to 0 to 1, d dot dy dz. Why? Because pi z plane we have considered here, plus integral z is equal to 0 to 1, integral x is equal to 0 to 1, then d bar into dy dz in the previous, dx dy in the previous. Now here x and z means dx dz. Okay, so like this, if you are evaluating means if you substitute d by first value, x and dx and dy means dx dy az, dy dz ax, and dx dz ay. See, so the formula for this d means we are considering that one with respect to az component. Az component means x is equal to 0 to 1, y equal to 0 to 1. So d bar in terms of az component. Az component means here what? X. So x into dx dy. Right? So plus. Similarly, y equal to 0 to 1, z is equal to 0 to 1, d. in terms of x direction means what is that x? 2y square plus z. 2y square plus z into dy dz plus integral z is equal to 0 to 1, x is equal to 0 to 1, then d bar means we are considering for this with respect to y, hence y means 4xy. So 4xy and dx dz. So like this, if you simplify the total equation and substitute the limits, upper and lower limits as 0 and 1, then you're going to supposed to get 2 coulombs. Why? Because in the part C, we have evaluated for the equation for Q enclosed. The charge enclosed and flux through any closed surface must be same according to the Gauss law. Hence, in the part C, we have been got the answer as here 2 coulombs, and this must be same. Then only the Gauss law is to be evaluated. Right? So this is the way you solve some of the problems based upon Gauss law. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.